And good morning, everybody. Here are your examples for IXL.com, Algebra 1, Module AA.8. And it's going to be a review of factoring polynomials, so there's not going to be a whole lot of new notes. It's just going to be going through examples of how to factor certain situations from the earlier modules, so it kind of reviews all of the modules in the AA section. So let's just go ahead and do a few examples of each factoring type. And here's our first example. This is one of the earlier ones where we have a lead coefficient that is 1. So we don't have a lead coefficient to worry about. So we know this is going to come from two binomials. To make the g squared, we're going to need a g times a g. To make the 6, we're going to have a few options. We could have if we wanted to find factors of 6, we're going to need maybe a 1 times a 6 or a 2 times a 3. But remember, these need to also add up to be the middle value, the 5g. So which of these two pairs is going to add up to 5 at the same time? So that's going to be the 2 and the 3. So we'll need a plus 2 and a plus 3. And those should be your two factors. And you can go ahead and check it by multiplying. So if I were to double check this, g times g is g squared. G times the 3 is 3g. 2 times the g is 2g. And 2 times the 3 is 6. So this is why we're looking for factors of 6 that at the same time have to add up to be 5 in the middle. Because if you simplify this, you get your g squared plus 5g in the middle plus 6 on the end. So that checks out. So this would be the answer right here, your two factors that go into the answer box. And here's another one where our lead coefficient is 1. So if we were to factor this, we're going to need a u squared for the first term. So we're going to need a u times a u. And we're going to need a 13 for the back term, so factors of 13. That's only really one option, 1 and 13. And they need to add up to be positive 14 in the middle. So to get the 14 in the middle, you need your 1u and your 13u. 1u and 13u is making the 14u. So that should be our set of factors. U times u is u squared. 1u and 13u is the 14u, and 1 times 13 is the 13. And here's another one with a lead coefficient of 1. So we need an s times an s to make the s squared. And we're looking for factors of the back. So factors of 10 that add up to be negative 7. So options for multiplying to get 10 are 1 and 10, or maybe 2 and 5. But notice they need to add to be negative 7, so we're going to need a negative times a negative to make positive 10. And then if they're both negative, when you add them, you will get negative 7. So it's going to be a negative 2 and a negative 5. And as always, you can check it by multiplying. If you do s times s, you get s squared. If you do, that's s times s. If you do s times the negative 5, that's negative 5s. Negative 2 times s is negative 2s. So there's the negative 7s that we had in the middle. And a negative times a negative is a positive, and 2 times 5 is 10, so we get positive 10. So s squared minus 7s plus 10, so that checks out. That looks like a good answer. So again, these are your factors that are going to go into the answer box. And here's one more with a lead coefficient of 1. So we'll need a p times a p to make the p squared. And we need factors of 8 that add up to be 6. So your options for factors of 8 are 1 and 8 or 2 and 4. And we know 2 and 4, when you add them, you get 6. So we'll put in a 2 and a 4. And they're going to both need to be positive. So when you add them, you get positive 2p and positive 4p to make the positive 6p for the middle term. And as always, double check it by remultiplying if you want to make sure you're right. So p times p is the p squared. P times the 4 is 4p. 2 times the p is your 2p. And 2 times the 4 is 8. So that's going to get us p squared plus 6p in the middle plus 8 for the last term. So it looks like that one checks out. And here's another factoring pattern that we studied in this unit. So this is what they call a difference of two perfect squares. So if you have a squared minus b squared, we know it's going to factor out to be a plus b and a minus b. So if you have perfect squares, then what's going to go in is basically the square roots. So for this first one, we have a q squared and a 16. So the square root of q squared is q. Q times q makes q squared, and 4 times 4 makes 16. So if we were to factor this, we have a plus and a minus, and then we need a q and a q to make the q squared, and we need a 4 and a 4 to make the 16. And those are going to be your two factors. And like any factoring problem, you can always check it by remultiplying. So if you do q times q, then you get q squared. Q times negative 4 is negative 4q. 4 times q is positive 4q. And a positive times a negative is a negative, and 4 times 4 is 16. And notice your two middle terms, those are opposites. Positive 4q combined with negative 4q is going to be 0q, so we have nothing left in the middle. So we get a q squared minus 16, which is what we were looking to create. So that checks out. And again, these are going to be your two factors that you're going to put into the answer box. And here's another example of a difference of two perfect squares. So notice 16y squared. The square root of that should be 4y, because 4y multiplied by 4y is 16y squared. And 9 is also a perfect square. 3 times 3 should get you 9. So it's going to follow that a plus b, a minus b factoring pattern. And we need a 4y to make the 16y squared. And we need a 3 to make a negative 9 on the end. And then your two middle terms are going to be opposites. So if you kind of look and see why this plus minus pattern is working, this is basically 12y. And this is basically negative 12y, which is getting you 0y in the middle. So that's why there is no middle term on these types of problems. And here's a review of a factor by grouping problem. So if you have 4 terms, then you can try factor by grouping. So if we look at the first group, what's common just between those first two terms? So between a 6 and a 9, you have a common factor of 3. And then between the m's, you have m to the third and m to the second. So the greatest common factor is going to be m to the second. That's the most value of m that they have in common. And what's going to be left behind, you're going to have a 2 and an m, because if you distribute the 3m squared back in, you get your 6m to the third minus a 3. So if I were to distribute the 3m squared back into the parentheses, you get 6m cubed minus 9m squared. And then if we look at the second group, what's common between those two terms? It looks like they have a 5 in common. So we can factor out a 5. And what would be left behind? We know for this to work, a 2m minus 3 is kind of what we need in order for this to work. So if you just write that in and then double check it, 5 times 2m should get you 10m, and 5 distributed into the negative 3 should get you negative 15. So it looks like this is going to work the way we need it to. So one of the factors is the common one that's in parentheses, the 2m minus 3. And the other factor is made up out of the two leftover terms that were factored out. So that's going to be 3m squared plus 5. Let's clean that up a little bit. So 3m squared plus 5 and 2m minus 3. And again, you can always double check this by multiplying. So these should be your factors. If you were to distribute everything back together, the 3m squared multiplied by the 2m should get you 6m cubed. The 3m squared multiplied by the negative 3 should get you negative 9m squared. 5 distributed in should get you 10m. And then 5 distributed against the negative 3 should get you negative 15. So if we check that, that checks out. So again, these should be your two factors. Those need to go into the answer box right up here. And here's an example of something with a lead coefficient other than 1. So if you have a lead coefficient that is not 1, then there's one extra step to find the correct combination of numbers. You want to look for factors of the back number times the front number. So we want to look for factors of 11 times 2. So factors of 22. So things that multiply out to be 22, but they're going to add up to be the middle term, negative 23. So if we think of our numbers that can make a 22, we know 1 times 22. We know 2 times 11. Which combination is going to make a negative 23? If they were both negative, so if this was a negative 1 and a negative 22, when you add them, you're going to get negative 23. And when you multiply them, a negative times a negative, you're still going to get positive 22. So it looks like those are going to be our two numbers. So what this is telling us is that the negative 23 in the middle is coming from a combination of negative 1 and negative 22. So we can rewrite the original function. So we'll call it 2n squared. The negative 23, we now know that's coming from a negative 1n and a negative 22n. So that's using this combination of numbers right here. That's where the the middle negative 23 is coming from. And then we still have the positive 11 on the end. And once you're here, you now have 4 terms, so you can use factor by grouping. So if we look at the first group, what's common? Looks like a value of n can be factored out. And you're left with 2n minus 1. And if you look at the second group, looks like you're going to have an 11 in common. So we have an 11 in common, but we also know that whatever is left behind needs to match what's in the first group of parentheses. So we need this to be a 2n minus 1, but notice we have a plus sign. So not only is there an 11 in common, but we also need a sign change. So what we're going to do is factor out a negative 11. And 2n minus 1 is what we need left behind. Just double check it, make sure that works. So negative 11 times 2n is the negative 22n. And negative 11 times negative 1 is the positive 11. So this looks like a good rewrite. And then go ahead and write down your 2 factors. So one of them is the common factor, 2n minus 1. And the other one is made up out of the 2 pieces here. So that's going to be an n minus 11. So that should be your 2 factors.